Now let's talk about some formula weight and some percent composition, okay? Formula weight, percent composition. We're going to do a problem or two on the front, and then we're going to try one on the back, and we're going to be good to go. So the first one we're going to try here is this guy, NH42SO4. So the very first thing we're going to do is we're going to write down every element that is in this formula. Now, I'm going to go ahead and clear out these other guys to give myself some room to work. And please notice how meticulously organized I'm going to be. I'm going to really write everything out. That way I'm going to prevent mistakes. And also, when I check my work at the end, it'll be easy to find a mistake if I've accidentally made one. All right, so I'm going to list out all the elements I see. I see some nitrogen. I see some hydrogen, some sulfur, and some oxygen. Now, before I go any further and I try and count these guys, I'm going to draw out, just provide myself with the visual for this ammonium sulfate just to make sure I know what I'm looking at. Now, you don't have to draw this out, but some people feel like it helps early on. So we have an NH4 with a +1 charge, and there's actually two of those guys, okay? That tells us that there are two NH4s with that +1 charge. You just got that one sulfate with a -2 charge. Just like that, okay? So, uh-oh. Raised too much, there we go. So that's what we're dealing with. Now, when you go to count your nitrogens, because what I want to do with these elements, and want to count how many I have of each one, you can see that there's a nitrogen here and here. So we got two of those guys. But you could, if you didn't ever draw this out, you could just see, hey, I have two ammoniums. There's one nitrogen in each one, so 2 times that one gets me 2. How many hydrogens? Well, I have 8. Okay, I got 4 in each ammonium. I've got the 1 sulfur, and I've got 4 oxygens. Now what I'm going to do is I'm going to multiply each one of these by their formula weight given on the periodic table for these individual elements. So I'm going to find nitrogen, hydrogen, sulfur, and oxygen. Nitrogen has got a formula weight of 14. Oops, I want to go ahead and do this. Nitrogen's got a formula weight of 14 right here. We're just going to round to the closest whole number. Oxygen's right next to it. I know oxygen says 15.99 something, but we're just going to call that an even 16. Sulfur's over here, it's got a 32. And hydrogen's just a good old number 1. Okay. Now you will probably memorize some of these as time goes on, but you never have to. You'll always have these masses provided to you when you need them, okay, on any quiz or test. All right. So I'm going to multiply each one of these by their individual masses. So nitrogen we just saw is a 14. So it gives us 28 from the nitrogens. Hydrogen's a 1. Gives us another 8. Sulfur is a 32. And oxygen's a 16. And there we go. Now, what am I going to do with all these? I'm going to add them all up to get that grand total. And I'm going to find this comes out to be, let's see here, 132. So my formula weight equals 132, and that's what I'm going to box up as the model student. There aren't any units for formula weight, so I'll just put FW, standing for formula weight, equals whatever your number is, and box it up. So that's probably the toughest problem on the front. That one, or maybe this guy right here, the calcium phosphate. If you're a little confused on that one, maybe give this guy a shot down here in the bottom left before moving on. But you should be able to calculate those formula weights, and we're going to use these constantly in Unit 6 and 7. So we're going to be using these all the way to April, probably. Now, so the first questions on the quiz, they just ask formula weight, and that's all I ask for. You can stop right here. But sometimes I'll ask you a slightly different question. I'll ask you about the percent composition of each of the following elements, okay? So I want to know, hey, what percent of this formula is calcium, what percent is fluorine, that kind of thing. And so you're going to have to look at the individual contributions of each element percentage-wise. Now, these problems, they start the exact same way. You're going to have to find the formula weight no matter what you do. We're going to go ahead and take a look at this guy right here, H2SO3. I'm going to start just like I did last problem. I'm going to list all my elements, H, S, and O. I have 2 H's, I've got 1 S, and I've got 3 O's. Now, the mass of any given H is 1, okay? Again, I'm getting that number from this periodic table, okay? This guy right there. And then oxygen was 16 from last problem, and sulfur was 32. So I'm going to use those numbers here. Boom. So I've got the 1 sulfur times this mass of 32. I've got the 3 oxygen times the mass of 16. When I add all of these up, I'm going to find that my formula weight comes out to be 82. Now, if I asked you for the formula weight, that's all you would need to do. That would be your final answer. But on this problem, I'm asking you for percent composition. So what we're going to do is this 82 becomes our denominator for these different contributions from the various elements. And I want to find out what percent of this 82 comes from hydrogen, what percent of this 82 comes from sulfur, and what percent of this 82, this formula weight, comes from oxygen. So I'm going to divide each one of these guys by 82. And this will give me some sort of decimal, okay? Be less than 1, it'll be a kind of small number. And then to kind of clean them up and make them a nice clean percent, I'm going to just go ahead and multiply each of those by 100%, just like this. Okay? So now, I'm going to go ahead and just plug this into my calculator. So when I plug in 82 or 2 divided by 82, and I multiply that, 2 divided by 82 comes out to be 0.024. And when I multiply that by 100%, it tells me I have 2.4% hydrogen. Okay. 32 divided by 82 comes out to be 0.39. And when I multiply that by my 100, I get 39%. And call it 0.0, I guess, just to be consistent here. You can just do 1 decimal on these. You don't have to worry too much about the rounding. Just be consistent. So I got my 39.0% sulfur. And then lastly, I'm going to come out to have 58.5% oxygen. One way you can kind of check yourself is that all of these numbers should add up. I'm going to box them up since this is my final answer. Notice I have each percentage labeled with an element symbol. So I know the 39.0% is for sulfur, not hydrogen or oxygen. Now all these should add up to about 100%. You'll see that my numbers here add up to 99.9%. That's okay. That's probably just a rounding thing. That's basically 100. So if you get 99.9 or 100.1% total, that's okay. But if you were to add these up and they came out to be like 72%, you'd be like, whoa, 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 that's a red flag. Something has gone wrong. Okay, so you're going to want to look into that. So feel free to knock out the rest of these problems. You can especially go for some of the saucier ones, like this guy right here is pretty tricky. So go ahead and give those a shot. Your quiz will go over not only just a regular old formula weight, which is what we did on the front with this guy, but you also need to do a percent composition, which requires you to do a formula weight and then to go ahead and find the percentage contributions of each element like we did here. Okay, please let me know if you have any questions. I will see you nerds next time.